now. Let me give an introduction on this. IET Young Professionals Sri Lanka started the series of e-talks earlier this year due to the social distancing restrictions we had during the COVID outbreak. So today we are having the fourth e-talk. The title is on infrared thermal imaging. Uh, I'll introduce the speaker for today. Engineer Shami Mudunkotuwa is a product of the Department of Electrical Engineering, University of Moratuwa, and a chartered engineer currently working for the Generation Division of Ceylon Electricity Board. Uh, he has great exposure, experience, and special interest in infrared thermography techniques for predictive maintenance. Being a level 1 and level 2 certified infrared thermographer of American Society of Non-Destructive Testing, he is one of the very few chartered engineers in the local industry who has achieved that level of certification. With his master's degree in electrical engineering from University of Morocco, he is currently serving as a contributing member in the 4-member steering committee appointed by the National Center for Non-Destructive Testing of Atomic Energy Board, Sri Lanka, for the purpose of establishment of the first ever training course on infrared thermography in Sri Lanka. Having ties closely collaborated with many foreign professionals on the subject with a vision, he is currently investigating the possibility of unlocking and expanding the industry potential for IRT applications in Sri Lanka to gain maximum benefit to the national industries through the best use of IRT. His other areas of interest, expertise, and enthusiasm lies in the establishment of effective preventive and predictive maintenance programs for excellence, instrumentation and control, coal handling equipment and process maintenance. Engineer Shami worked in Lakuja Power Station for nearly 7 years in his career. So, without taking much time, I'll hand over the session to Engineer Shami Mudunkotuwa to continue on his presentation.
Thank you very much, Priyanka, and a big thank you to the IET Young Professionals main committee and the IET main committee members as well for initiating such a great movement during the most trying times we have experienced in most of our lifetimes. And a very good evening to you all joining us today. And I'm also a active. I used to be an active IET member back in the undergraduate days with close ties to the main committee. We did a lot of events, and it's really happy to see that the movement far away, I mean, many years ago, have been evolved to such an amazing movement right now. And so without further ado, I will give an introduction on this subject because the infrared thermal imaging is a very underrated, I would say, technology in the Sri Lankan engineering industry, because I have seen many devices around the industry, but I hardly see the owners of those devices reaping the full range of benefits from these devices. So I thought with my little bit of experience I have, I thought that I should share the things I know with the general crowd right here. And within this presentation, please feel free to stop me anytime for some questions, and we'll be taking questions anyway at the end of this session. And since we have to cover a lot of area today, so I will get on with the presentation. Yeah, a short introduction about myself, and this was mentioned by Priyanka. And my special interests lie using this infrared thermal imaging for predictive maintenance, and there are quite a lot of applications. I assure you that you will be surprised to know some of these applications, especially the non-engineering applications we will share today through these images I have from my peers from the international arena of imaging. And also, if you have any questions or you would like to share your view on these technologies, on how to move on locally, you can always send me an email and you can give me a call. And um, so the main um, target today for me is to talk about unlocking the true Sri Lankan potential for this, because we have enough number of devices here. We don't need any imports coming here, and the number of devices is very much adequate to the unlock the potential. But the thing is, there is a huge gap in the skills and the technical know-how to use these devices. So I'll be focusing on more on the applications and where to use this technology. And today, in this session, I would like to get on with some basics, back to basics to the high school on infrared radiation and a bit of history, concepts and devices, what are the classifications, what they can do, what they can achieve, um, and the industry aspects, and about a little bit about training and certification and the surveys, and finally on unlocking the true potential and skill building. Yep. Back to basics. You know this from your high school and even your advanced levels. There are three methods to flow for the flow of heat, and there is a source, and it could be either conducted or convected or radiated. So the physical sensation we feel through the heat flow can be measured through the temperature. The temperature is the only entity, only physical entity that can be felt to the human being. So that becomes the deliberate, obvious measurement parameter for these uh, when it becomes to heat and the and thermology. And this infrared thermal imaging or any sort of thermal phenomena has very close ties to on how do materials react to the heat. When they receive heat, how do each material react? um, these parameters like specific heat capacity and thermal conduction coefficients and radiative coefficients and convective coefficients, and how the atmosphere interfere in all this. It's really interesting, and those concepts provide the basic um, foundation for the thermal studies. And today, yeah, a little bit about the temperatures we are going to measure. So as you know, there are four temperature scales in practice in today's world, and two of them are relative and two of them are absolute. Celsius and Fahrenheit are relative scales in the sense that they are in relation to the freezing point of the water and boiling point of the water. They are the main underlying um, relative event existing in the physical world that defines those two temperature scales. And unlike them, the Kelvin and Rankine are the absolute temperature scales in the sense that they're absolute. For example, 0 Celsius means that the freezing point of the water, but the 0 Kelvin means the absolute zero, which means the temperature that the for example, take a target. The target has some sort of a temperature in it, and thermal energy stored in that target. But if you keep on cooling, the those particles in that sample will stop moving at the 0 Kelvin or the 0 Rankine, because that is the absolute zero achievable. But mind you, the 0 Kelvin and 0 Rankine cannot be achieved practically because they have been trying to freeze and freeze and freeze repeatedly and through some special processes, but they have not been able to achieve these temperatures as of now. The closest to the 0 Kelvin that they have attended was the one in to the power 1 over the power of 14 to the 10. That is how close they can get, but they so far they have not been able to achieve 0 Kelvin and 0 Rankine. The absolute 0 is not practically achievable right now. Yep, moving on with some thermal physics. The radiation after the three methods, conduction, convection, and radiation. For thermal imaging, the radiation is the prime method of interest for us. Because these devices, they don't measure conduction or the convection. They measure radiation, and that is by design, they only measure the radiation. And by radiation, if I'm going to talk about more on radiation to simplify things for you, these energy photons on the target will absorb the heat or the thermal energy from the target, and they will travel through the space. That is the basic, the simplest introduction for the radiation. These photons, they will travel in space. They are electromagnetic waves, and they are freely moving. And there are equations built on this radiation. Then the main equation, obviously, is the Stefan Boltzmann law, which most of you know from your high school studies. Stefan Boltzmann law is talks about the bodies, the type of bodies, and how the radiation emits, and what type of parameters affect the radiation emitted by a certain body. The black bodies, gray bodies, and real bodies are the defined type of bodies. And Stefan Boltzmann, these two gentlemen, we'll be talking about them in later on in the history studies, which in their cutting edge research, they have found that the black body is a perfect body that emits all the energy. The full amount of energy it has will be flown through in the form of photons to the energy, to the atmosphere. And there are no temperature differences in this body. The gray bodies, on the other hand, will emit full amount of radiation, but they can have uniform, they cannot have uniform radiation throughout the wavelength. I'll be speaking about the wavelengths in the slides to come as well. And the real bodies are the ones we see around us today. So those are the three types of bodies that Stefan Boltzmann law talks about. And this is the modified equation of Stefan Boltzmann. And you can see the emitted radiant energy only depends on two factors: the absolute emissivity of the body and the absolute temperature of the body. Mind you, this is the absolute temperature of the body in Kelvin or in Rankine. I'm sorry, in Kelvin. This form of the Stefan Boltzmann law talks about the Kelvin scale, and the Stefan Boltzmann constant is a universal constant. It does not depend on anything. It's a universal constant. So you can see it's really simple. The radiant energy emitted depends on the emissivity and the absolute temperature. It's that simple. So the temperature is the one thing that we are trying to measure, right? To these devices, infrared thermal imaging devices, what we need to know is the temperature. So these sensors will detect the emitted radiant energy and provide us the temperature. That's how the devices work. And the emissivity here is the main factor, or probably the most important phenomena we are talking about when it comes to talking about the radiation physics. The emissivity is of prime importance, and we'll be touching the emissivity in detail in slides to come. So I was talking about the infrared spectrum. So thermal physics, these photons, they usually travel in the infrared spectrum. Infrared spectrum, of course, has many subspectrums. We are interested in particular from 2 to 15 micrometers of the wavelength. Usually from 2 to let's say 4 micrometers, it's a shortwave infrared, and 8 to 15 is the long wave, which we will be mostly talking about. The long wave infrared has many applications, and beyond 15 micrometers, of course, there are not much of an interest as of now, but there are very, very specific applications in the far infrared wave subspectrum as well. Yep, bit of history right here. And Sir William Herschel is the father of infrared. His discovery happened in 1800. And today we celebrate the International Thermography Day, Infrared Day, on 15th of November, which is his birthday. And these two gentlemen, Joseph Stefan and Ludwig Boltzmann, are the fathers of the blackbody studies carried on the radiative physics. And they developed uh, the Stefan Boltzmann equation and the many formats of it. And they have, these three gentlemen are the reason we have our devices troubleshooting many saving the losses and saving assets from fires and whatnot. So you must as a professional, everyone must remember these three gentlemen. Okay, so devices have been evolving ever since this was discovered, and I'll be talking about classifications. There are two types. There are fixed instruments, there are portable instruments, there are instruments based on the sensor type, there are point sensors, there are line sensors, there are focal planar arrays, which are the most common type of sensors we see today, and the fixed applications and portable applications. And I'll be touching some device specifications as well, like the focus, the range, the radiometrics, the accuracy, and the sensitivity, and the optics, everything. And I'll be talking about device maintenance as well. Here, the device maintenance also has been very poor as per our observations done on these devices, because I have seen some terrible maintenance practices for these expensive devices, which will surprise you. I mean, you should. I mean, we would have never thought that that particular practice for device maintenance would obsolete your equipment. So I'll be talking about that as well. Um, yeah, device evolution. Yeah, I was surprised the first time I saw this, as you are. And in 1960s, when these commercial devices were first introduced, um, they were pretty big. They were pretty big, and the main reason for that was the first generation of infrared sensors. Um, when they first developed, the condition was that they required significant amount of cooling. So obviously, when something needs cooling, the device gets bigger. So that's what happened in 1960s and 70s and 80s, until the uncooled microbolometer was innovated by a leading company. Also, I would like to, when it comes to devices, I am not endorsing any devices here. I have taken steps to remove some names from the images I have used, because I don't endorse anything, and I don't personally believe in a particular brand as well. Thermographers, the professionals, must be able to work uh, any device, irrespective what the brand is. The things you should be worrying about is the specifications of your device, not the brand. And yeah, back in the day, the devices were really big because they required cooling, and the uncooled microbolometers gave a whole lot of meaning, and that was actually a game changer for thermal imaging devices. So you can see in 2016, this device, the phone attachment, which you see on the right, came out, and it was a game changer, absolutely. And these devices, from being professional equipment, now has become a very common instrument in your household. In the Western world and the US, and these images, uh, they're used for domestic work as well. It's very surprising, but that's how the device has evolved and enabled market transformation for these devices to become game-changing instruments. Yeah, a little more uh, from the old archives. These are the devices they used back in the day. So you can see there are some cooled nitrogen tanks in these devices, and they were massive. They were really bulky. And imagine um, carrying one of these to your survey today. And yeah, I know it's really, it's unthinkable basically, because we are really lucky to have these devices with us today. And you can see they are very smart, really handy, really compact and capable. The capabilities are really, it's game changing. So today you have Android mobile phones with inbuilt thermal sensors. So which one of the devices on my bucket list right now, because it's not released in Sri Lanka yet. But I've crossed my fingers for this device. So you can see these devices are very handy right now, because thanks to the uncooled microbolometer technology, the sensors have uh, become smaller, and the devices obviously became smaller, and they have really amazing capabilities right now. I'll be speaking about these specifications and the devices later on. Yeah, let's talk about the classifications. We have fixed types like the CCTV cameras we have today in our public places, and we have fixed cameras, we have dome cameras, we have cameras that the tripod mounted ones, and these are for basically for health and safety applications and security surveillance and fever detection. Actually, the fever detection has been a quite lucrative business lately with the breakout of the pandemic. These fever detection cameras, there are many myths um, and misconceptions with regard to these fever detection cameras. I'll be touching on those as well. And we have portable instruments. The most number of instruments we see today in this local industry are portable instruments. We have handheld and vehicle mounted. We'll see some images of these applications later on. And there are emerging devices and applications such as medical ones. I have hardly seen any medical thermography applications in Sri Lanka. I see some doctors joining us today. Perhaps they can share their experience and expertise. That's because that's what all about this presentation for me today. Is not me talking about what I know, but I would like to hear from you, and really about these applications, because uh, we will not we can get together and share our ideas to draft the way forward on become this on this technology. And we have aerial applications, maritime, transport, firefighting, R&D, and domestic users. And this gas imaging, actually, OGI, optical gas imaging technology, has been a very popular technology lately, where you can detect gas leakages like methane, liquid petroleum gases, and SF6. It's quite handy actually, these applications and devices coming out nowadays. Yeah, classification number two, which is a sensor-based one, because based on the sensor, there are devices in the industry. So this is the first one is the point sensing. In these devices you see here, there is only one infrared sensor, only one uncooled microbolometer sensor, is used for the application. So the fever detection cameras we see on every place we go today has one of these. It has one uncooled micropolarimeter sensor in it, and the second one here is the spot radiometers we see before the images, the thermal images came to the picture. These spot radiometers are really popular. Even in today's industry, we see a lot of spot radiometers. And the third applications is, of course, the line follower robot. I'm sure many of us here can relate to this application. Probably one of our first robot in the university competitions and projects. It has for the line following capability, it uses one infrared sensor. That's how um, that particular sensor um, will distinguish between the black and white lines based on the color. And we have line arrays. Probably it's an extension of the point sensing where we have multiple point sensors arrayed up into a line. And the applications are basic robotics like the one above, and the land surveying. For some of the land surveyings aerially, they use back in the day, actually, in the late 80s and 90s, they used these line array systems because what basically it does is the aerial moving system, probably an airplane, has a moving scanner, and the scanner, while the scanner moves back and forth, these line sensors will capture the temperatures through each sweep. So that's how they record the readings. And yeah, the most applications we see today have these focal plane array FPA sensors, which carries a centrum matrix. It's a extension of the point sensing capability lined up into an array. For example, we have one 80 by 60 arrays, we have 120 by 180 arrays, we have 160 by 120 arrays, and the multiples up to 1024 into 860 arrays. So you can see the first one here. This is the aerial system. This is an aerial system where it has a FPA. The applications are search and rescue and land surveying. And the second one is a handheld portable camera. So as the third one and the fourth one. And this fifth one is a machine learning application camera with a very high resolution. And this one right here is used in border patrols to monitor the movements of the illegal immigrants. Yeah, it's a surprisingly affordable application, and you can see one of these now mounted on a vehicle right here. It's the same type of sensor here, and what they do is during the night, they deploy these vehicles throughout the border to track the thermal signatures, because at night the land is cooler, but the body heat of the illegal immigrants cannot be hidden. So using these thermal images, these very sensitive, high resolution FPA array cameras, they can detect illegal immigrants coming from a distance, actually. So that's a very common application. And this one right here, the final camera, is the thermal sensor used by US drones, the Reapers, as we call it. During you can see there are several openings in this camera. They have multiple thermal sensors and visual sensors mounted onto these Reaper drones, where they carry out reconnaissance um, rendezvous missions for days. Actually, they stay about around 30,000 feet high in the air, collecting information on vehicle movements or any thermal signatures they can capture. They use these images, these devices on their Reaper drones. To speak about the main specifications we see in these devices, like I said, the higher the resolution, the higher the capabilities of detection, because you can be scouting on these illegal immigrants using an 80 by 60 sensor. You would at least need a 640 by 480 sensor, which is about 32 times the resolution of this sensor. So the application will decide the thermal resolution of your camera. But for a domestic application, for example, you say you need to see a hotspot in your local distribution board, electrical distribution board. 80 by 60 thermal resolution is more than enough for that. And again, if you are trying to look at a distribution, a transformer which is around 5 meters high in the air, you would at least need a 320 by 240 camera here. So like that, depends on what you're trying to see and how how to resolute that target you're trying to measure. And the temperature range, of course, we have applications and capabilities going beyond 1000 degrees Celsius easily. I have seen special custom made cameras to measure 3500 Celsius degrees, which are very specific and advanced applications like boiler combustion testing, boiler fireball monitoring, like that. And also this radiometric and non-radiometric is a really important parameter when you are trying to buy a camera. What it means that, say, if you are looking at a 80 by 60 sensor, you would have 4,800 individual thermal sensors measuring temperatures. So if you have a radiometric imager of 80 by 60, you would have 4,800 measurements in that photograph. But if your image is non-radiometric, you will only have that particular one spot you are trying to measure. When the image is captured, you will only have one. If you are trying to measure another spot of the same frame, you would have to re-measure it. But with radiometric capabilities, once you capture the thermal image, you will have all the 4,800 readings in one picture. So if you are buying a thermal imager, it is highly recommended to check for this radiometric capability, because the price gap between the same resolution radiometric and non-radiometric images is significant. But it's worth the money, I would say. If you are buying an imager, depending on your application, a radiometric imager is highly recommended. If not, you will not have the full range of readings on your image. And these days they have a visual camera inbuilt, because they have these interpolation techniques where they will put your visual photograph and the thermal image together, and they integrate the two images and create one. And it's better to identify certain components in let's say we have a very dark, very low light condition. Using the inbuilt torch or the lighting phenomena, we can identify those components easily with the thermal resolution and the pattern on it. And the accuracy and sensitivity, remember, the images you have will only give you a 2-degree typical accuracy, meaning that you cannot use your industrial thermal imager using in the factory to measure the temperature of your personal. You cannot use it as a fever screening device. provided. However, some of the images have this special module inbuilt for elevated body temperature scanning. That mode will provide an additional improved accuracy up to 0.2 Celsius degrees. If you have that EBT module inbuilt, you can use it as a fever screening camera. If not, you will only have a 2-degree typical accuracy for your image visage, which is quite useless for fever screening. And the spectral response means that we spoke about the infrared spectrum was divided into 4: the short wave, the medium wave, the long wave, and the very long wave. And if you're buying an imager, depending on your application, you need to decide the spectral response, because most of the applications will lie in the long wave, which is from 7.4, 7.5 microns to 40 microns. But there are certain very specific applications for short wave and medium wave. So be careful about it. And field of view will decide what you see. And the external optics will provide additional accuracy. We will be speaking about the FOV and the external optics in slides to come. And the frame rate, yeah, this is important for certain applications, because typically you will have a 9 Hertz frame rate for any imager you buy in the market today. And if you're trying to monitor someone, for example, say the Reaper drone is spying on a high profile a target in Afghanistan, so you can do it with 9 Hertz imager, right? So the target will be moving, he'll be getting onto a vehicle, and he'll be moving around. With the 9 Hertz frame rate, the frames will break. His movements cannot be tracked continuously. But if your imager is 60 Hertz, your device is 60 Hertz, the movements will be silky smooth, which will enable you to track the movements of your target. Same with the search and rescue. If you are trying to look for a boy who has got lost in the jungle, which we'll see some photograph in the slides to come, you would definitely need 50 or 60 Hertz frame rate in your device. Yeah, really important. If you have a device, carry the case with it. If that is a high-end device, you will have a hard case, use it. Don't carry the imager around without it. You will regret it. And the lens or the optic lenses are the most important part of your imager, because it protects your sensor. So keep it debris free. If you see some dust, use a warm cloth, because what most people don't know is that your lens has a very specific advanced coating on it, so that your lens can let the infrared photons through to the sensor. So I have seen, like I said, I have seen some people removing this coating. I have seen some images in which they have accidentally cleaned the lens with some alcoholic solvent, thinking that it will be better after cleaning, and the alcoholic solvent has damaged the coating. It's gone. When it's gone, your imager will act like a opaque device to the incoming photons. Once the photons won't land on the sensor through the imager, your readings will be well off. So be careful with the lens, because there is a special coating. If you take your device out, you will see that your lens is really shiny from the outside. The reason is that there is a special coating to enable the photons inside the image sensor. And the body you can of course clean with a wet cloth. No solvents are recommended because mostly these images have rugged rubber um, exterior, which can cause a negative effect with the alcoholic solvents. So be careful about it. And keep it charged always. If you have a survey tomorrow, charge it today to the full 100%. So don't let it undercharge or go dead for a long time. It will be gone forever. You will be prematurely expiring your um, battery. So be careful about it and mindful, and always do the functionality checks before every survey. When it comes to functionality checks, you can measure the boiling water. Be careful, and you can measure the melting ice, and you can measure the tear duct temperature of someone you see around to check whether the readings are within the range. If the checks are off, for example, if you are looking at the boiling water, you see around 50 degrees, say, which goes on to say that your calibration of your camera is well off. It's time to send your camera to the manufacturer for the calibration checks. And they will fix it and they will calibrate it and send back to you. So that's how you know whether the calibration is required for a device or not. And um, also be in sync with the OEM for updates. It's really important that you talk to your manufacturer, and because there are timely updates coming. For example, for the most of the devices, the all devices did not have the particular EBT module inbuilt. But with the pandemic, I have seen some OEMs, they roll out some updates for these devices so that they can be um, used as a freeware screening device. Same way, you need to be in sync with your OEM and updates always. It's not like that. It's not like you buy your camera right now and stay. I mean, keep on doing surveys without checking for updates and news on the supplier. You have to be in close contact with them. Yeah. So we'll be talking about some concepts, and I'll be rushing through these as we are a little bit short of time, seems. First we have to understand that there are all limitations to both contact and uncontact measurements. Contact measurements, there's something we do at our home when you feel feverish, and we take out the uh, mercury thermometer and put it under our tongue to measure. Those are the contact measurements. And always remember, the non-contact measurement accuracy is less than the contact accuracy. That we should know, because non-contact measurements are fast and safe, remote, but expensive, and the accuracy may be lower. The contact measurements, since they are directly in contact with the target, always will give the higher accuracy compared to non-contact measurements. But say the target is not safe to touch, you can touch it and it's very remote. For example, if you are seeing a load brake switch, say it's about 10 meters high from the ground, you can reach there and you can touch it either because it's energized. So the non-contact measurements come in handy in occasions like those. Yeah, if you're trying to be a professional in this, you need to see this as an art, like the photography, like the wildlife photography, because the wildlife photographers, they wait for the moment, and when they see one, they capture. Like that, if you have an have a passion for the infrared thermal imaging, you need to see it as a form of art, always. And things look really different and interesting from the thermal domain. I'll show you some photographs, thermograms, so you will see. And bearing these in mind, we'll move on to some more concepts. Say you have a target at T Celsius degrees. It can be a piece of metal, a piece of plastic, or anything heated for a temperature. So you have the atmosphere around it, which will absorb the radiation and attenuate it, and the relative humidity, and maybe some debris, some smoke, and you have your instrument with you. And when a measurement takes place, you can see here the epsilon, the emissivity of the from the Stefan Boltzmann equation is a material property. And what you are trying to do here is you are trying to measure the temperature of this target through your instrument. So this is the emission you are trying to measure, and that is the emission, the component we are interested about. It is here the energy, the emitted energy is denoted as W epsilon, which is captured by the instrument. But that's not the only thing captured by the instruments in this instant. You have, for example, if the target is thermally not opaque, there can be photons traveling through the target into the instrument. So we'll say that the energy from the transmission is W tau, and the transmissivity is tau. And then we have the surroundings and the atmosphere. We have the reflections. We have atmospheric surroundings. We have the sky reflecting through the shiny metal. And the reflection will also be captured by the instrument. So you can see here, the instrument will not only capture the emitted energy, but it will also capture the transmission and the reflection. So if you are trying to measure this T temperature through the emission, it's important that we cancel out or account for these two, reflection and the transmission. So how to do it? And these three properties of the materials are extremely important to do this. And the Kirchhoff's law for infrared physics say that the addition of these three components is equal to 1. Let's say the target is human skin. So the human skin has an emissivity of 0.98. Actually, the human skin is one of the best emitters existing in the world right now. And there is no transmissivity, nothing can pass through our body, not thermal imaging, not on all spectral domains. And the reflection is very less compared to the emissivity. The reflectivity is less. So what happens is, since the imager captures all three components, we need to cancel out these two and get this component into calculation to calculate the temperature. So emissivity is a target property, and unfortunately, it's not a constant. This is another misconception and a myth in the industry to use the emissivity. The thing is, these devices, infrared thermal devices, usually come with an option to input the emissivity. You can define the emissivity from 0 to 1. Some professionals in the trade tend to refer these emissivity tables given for certain, let's say they are trying to measure a copper bus bar temperature. So they look at the table and they try to get the emissivity from there, which is not the best practice, which can lead to many errors in the reading. And the emissivity also varies with the temperature itself. For example, these emissivity tables, always remember the emissivity tables are given for a certain temperature, probably for the room temperature, at about 26 Celsius degrees. And when the target temperature increases, say 100, 200 degrees, the emissivity decreases. So if you are trying to measure the target temperature at 200 degrees, your emissivity table value is no longer valid. And the angle and the geometry of the target you are measuring, you need to measure direct in line 90 degrees. If you're trying to move around, if you are trying to angle the device to the target, it can change the emissivity and the measurement temperature can go off. And the spectral range and the surface textures like that. Remember, if the target is a shiny metal, it's very low in emissivity, which can mean about 0.09 emissivity at 38 degrees. This value is taken from a emissivity table. And painted metals, they have very high emissivity at around 0.9, which is a very good value. And usually if the material surface is rough, it's high in emissivity. For example, a fired clay pot can have a emissivity of 0.9. And when the target temperature increases beyond 38 degrees, there is no telling how the emissivity would vary. So, like I said, emissivity tables is not a good idea. It's actually a very, very bad idea. And you should not be using them, actually. There are other techniques for these type of applications. For example, when you are using the, say you are using the copper emissivity, copper has many shades. They are bleached, they have oxidized, and if it oxidized, how do we know the severity of the oxidization? Without it, we cannot decide the emissivity. So using the emissivity from the tables is a bad idea. So if we have low emissivity and the reflections are high, so few tips would be to modify the surface if possible, if it is safe to touch, and test with a sample. If you have a sample of it, there are methods to measure the actual emissivity. And sometimes when you see a reflection from a target, like the King Julian said, you need to move it. And if the target, the reflection moves with you, that's a reflection. That is not a true hotspot. And as the subject is very, very particular, the professionals must train and understand the essentials. The training is paramount when dealing with the low emissivity and reflections. And once again, I would like to emphasize the fact that using the emissivity tables, it's a not good idea. It's not. And I will be talking about some applications here. Electrical, mechanical buildings, and some non-engineering. The non-engineering applications have some medical and equine, livestock monitoring, and these applications will survive you. Surprise you. I'm sorry. So basic electrical applications, you have high resistive connections. This is a low voltage transformer, and we have seen enough of these through our career and during my work at Lakvija Power Station, and we have seen many, and we do continuous monitoring. And when you see this, you can see here the maximum temperature is 130.2. Celsius degrees, which this is a hot spot. This is a really hot spot, and the hotness gradually decreases through the cable, which says that the source of heat is here, right? You can check the scale here. This is the temperature scale, and the color palette says that the purple is the coldest and the yellow is the hottest. And you can refer the scale and see what's hot and what's not. And there can be load balances problems, load failure, and improper balance, which is a very common issue in the industrial environment. So you can see the phase here is the hottest, and this is comparatively colder, which says that the three phases are not equally loaded. And we have seen cases where one particular phase is very cold, which says that the phase is failed, which can be. It's a possibility. So using other instruments, you can check the voltages and currents through the phases to pinpoint what the issue is. So this is a very interesting application. Failure mode. Usually when you have three-phase cables going entering into a panel, there can be inductive heating through eddy currents. This is a really interesting photograph by my man Ivan from Thermospec Australia, and we have seen this enough. We have seen this enough, and usually what we do is to prevent this from happening. We usually have a cut through the cable entry plate, so that the circulating eddy currents would not be possible. And there are some many applications in high voltage and medium voltage with distribution stations and transmission stations. On the right, you can see a load break switch. It's a hotspot. You can see if you look at the temperature scale, it's really hot, and the rest of the components are cold. And on the left, you can see a voltage transformer. There are some hotspots here, which have been indicated by circles. So those hotspots can be identified. This image is, by the way, from Luca Maragviglia from Dark Wave Thermal Imaging Italia. So there are many components and many applications in electrical. You have breakers, you have bus bar systems, voltage transformers. Breakers, of course, you can monitor the contact points. You can monitor the internal contact strength. And the bus bar systems, of course, is tricky if they are naked. Like I said, the shiny metals are low in emissivity. For bus bar systems, we highly recommend having emissivity improvements through sleeves. There are heat sleeves, bus bar sleeves, which can significantly improve the emissivity of the bus bar, enabling later on troubleshooting in possible loose connections or misconnections. And voltage transformers, terminal bars, and magnetic contactors are also a key component in most control panels. With time, the magnetic coils, the contactor coils, and the contacts can develop issues. These can be identified using the thermal imaging. And transformers are very important assets in any instrument, in any installation, and we can identify loose connections, cooling issues, and blocked radiators. Yeah, that can be easily identified through thermal imaging. And solar panels and installations is a very nice application. And we have seen many solar panels in the local market industry, once they are installed, there are cell level defects, a lot of them. And through thermal imaging during the peak hours, you can see the hotspots on the solar panels. And of course, the inverters also can be monitored. The cooling issues can arise in the inverters. And by measuring the exhaust temperatures to thermal imaging at a glance, we can easily identify potential problems. So, mechanical applications, motors, bearings, and couplings. There are these two images which we have captured um, provides good idea about the motor winding temperature monitoring, the bearings here, the bearing, and the coupling here. This is a fluid coupling, and when you see a temperature or we say the thermal pattern, you can easily identify a problem. Usually the windings, as a rule of thumb, usually the motors, the windings, and the bearings must be low in temperature. So in this particular photograph, in the one lower, on the bottom, you can see a hotspot, which is not supposed to happen. And upon inspection, we saw that this is due to a acute bending radius of the cable, which is surprising because the acute bending radius will reduce the current carrying capability of your conductor. So this is the fluid coupling, which is within range. So these boxes are area max boxes, we call them. They are very handy when it comes to thermal surveying and reports and analysis. And these are some gearbox applications. You can see this is a gearbox driving a conveyor. You can see the hotspot in it, and the one below is the pulverized coal mill gearbox. Right here is the gearbox. The gearbox is fine, and you can see a hotspot on the grinding table, which is obvious because the grinding table usually uses heavy balls to grind the coal, which will probably induce some stress on the grinding table, which will result in increases in temperature. Yeah, this is another application, missing thermal insulations. You can see on top, this is a kiln of a tile industry application. So you can see here there is a missing insulation. With these images, you can easily identify these missing insulation. On the bottom, you can see a stack that carries a exhaust gas to a regenerating heat system. So obviously there is a missing insulation here. So you can identify and do the needful. And there are some asset monitoring applications, special assets. So on top, we have a turbocharger of a diesel generator. And when the temperature of the turbocharger is high, you can see that there could be a problem of engine misfiring, or can be improper combustion, too much carbon in the suit, things like that. So before the problem arises, you can identify this and take the needful actions to prevent unwanted, unplanned downtime. And the image below is another critical application where we have noted this is the coal flow entering the bunker, and you can see this coal flow hitting this bunker buffer wall and causing abrasive thermal effects on the walls. So here we have identified this particular location is a lining, a special lining to address the abrasion abrasive thermal heating. Likewise, we can carry out many monitoring of the critical assets. So there are many other components. I'm not going to go into each of these. There are V-belt systems, drivetrains, and if the V-belts are not matched, if they are over-tensioned or under-tensioned, you can tell through this technique. And the valves, if they are leaking, if they are blocked, if they are not operating like they are supposed to, you can identify through this technology. Steam traps, air leaks, heat exchangers, and tank level monitoring are also very common applications, especially if your tank is having a underlying sludge layers. You can easily see through these devices. So this is a unbelievably amazing application of the thermal imaging. The medical thermal imaging and veterinary medicine thermal imaging applications are very common in the other parts of the world. This is a application of a. These images are from Thermo Horse, France, from Memorial, who is a jockey before he got injured, and now he's in the business of horse monitoring. He monitors the critical joints of a horse to see the health condition. If there is an upcoming development of the in the body of the horse, they can identify uh, well before, because these horses will be running races, and these conditions can very well mean the death of the horse. So they see these horses as uh, assets, and they monitor them. You can see there are some issues in the joints, and there are some issues in some horses, the shoes they have installed. So likewise, the Sri Lanka can um, monitor our cattle. You know, there are some imported dairy cattles, cows we have imported, and if they're having some infections in their organs or externally, through these images, you can easily monitor. So these are some medical applications similar to the equine thermography, and the image on the left is my own leg. You can see the blood circulation levels, and there are some applications in the industry to detect issues like blood sugar and the possible acute leg nerve loss in the legs and other in your limbs like that. And the image on the right is from Dr. Sandy Chambers from Skins IR, US, and where they have detected a problem in this woman's right hand. There is a joint pain, and they can easily pinpoint what the problem is from the thermal pattern. Actually, this is for this application, you would need a very high resolution camera because you are looking at a large area. I'm sorry, a small area with for very tiny amount of details. So fever
This is
monitoring.
Shami. We couldn't see the slides earlier. I think there's some problem.
Oh,
We are
okay.
stuck in the mechanical components to watch out. That's the slide we are looking at the moment.
I see. What could be the problem?
Maybe you can disable the screen sharing and start it over again.
Okay. Okay.
Now it's okay.
It's not on the show, right? It's not continuing for some reason. All right. Can you guys hear me?
Yeah. All good.
Okay. So like I said, in the other parts of the world, they monitor their horses and valuable animals through this technology, and you can see there are some muscle issues um, in this horse and some shoe issues on the right, because one of the shoes are hotter than the other, and there are some joint issues probably here. So they usually monitor their animals and take the needful actions, probably veterinary measures, to make sure that this animal is healthy for the races. Um, these are some of the medical applications I was talking about. If you are having a blood circulation issue or a um, blood circulation issue and some body pains, this technology can help you to pinpoint the exact problem. If you are, especially if you are diabetic, if you have some numb feet and some limbs or some part of your feet are not feeling good, you can use this technology to pinpoint which components are suffering from that condition. Um, so this is the fever monitoring um, application I was talking about. So these images are inbuilt for that. You can see this image. The woman is being monitored for her temperature. Yeah, these are the applications I was talking about before. There are huge military and SAR. SAR means search and rescue market in other parts of the world. I have seen in Sri Lanka also, they have been monitoring these lockdown districts using thermal imaging enabled drones, which is a really good development locally. And remember that we need the 60 or 50 hertz frame rate capability for these applications. So on the right is a real image um, used to a real case where a person was lost in a jungle area and they could not find him. And thanks to this thermal imaging technology, at night even you can see this. This is the night. All the both of these are night captures. So you can see since the um, the human body is around 36 Celsius degrees, and at night the background is comparatively low in temperature, so the contrast enables you to see moving targets such as animals, if the animal is not cold-blooded, targets like that. And firefighting is also a very common application in the world, because during a fire you are moving in a very risky environment and through a lot of smoke. The main focus here is to enable the firefighters to see through the smoke, because thermal images can see through smoke. The atmosphere will, of course, will certainly attenuate the signal for some extent, but the photons will still travel through the smoke. So the firefighting applications is, I don't think we are using this technology in Sri Lanka, but we should be using, because it is very easy to identify survivors within the smoky environment when it comes to a incident. So for manufacturing applications of this is some images from a tile manufacturing application, where on the left you can see tiles coming out from the kiln after being burned, subject to the very high heat. So by monitoring the temperature of the tile, you can predict the quality of this product, right? You can check the pattern, whether this tile is evenly hot, whether the temperature has been applied properly, and accordingly the quality can be decided and rejected. So likewise, there are many applications in the manufacturing QA and QC. And some industry aspects here. There are many governing standards and articles when it comes to this area. And the main the governing article is the American Society of Non-Destructive Testing recommended practice. They have a 2020 upcoming update, and for evaluation we use the bottom one, cntd 2019 standard for maintenance testing specifications. These testing specifications decide how hot is too hot. For example, when you see a conductor hot up to 100 degrees, we know that the conductor insulation is maximum 90 degrees possible. So we see that it's a exception and should be dealt with immediate actions. Likewise, there are other publications defining general principles, criteria for qualification and certification, and condition monitoring, and how it should be done. And the number 4, NFPA 70 Bravo, which is published by the National Fire Protection Agency, is also a key article in this aspect that decides the loading conditions and how the measures should act, what are the capabilities of the measures should have, and etc. And the ISO also has some publications out in IR point of view, and they have also been very specific about certain things. So industry aspects, if you are trying to get a photograph, the thermographer to do your survey, can anyone do it? And the answer is yes, anyone can do it, but the problem is, can they provide you a report? Can they interpret the results? So the answer lies here. So the SNT TC1 and ISO standards specify that there should be 3 levels for infrared thermal imaging competency. And level 1 competency is only can capture and record data under the supervision of a level 2 thermographer. And they are not permitted to interpret the results and provide a report. they can't do that. And the level 2 can carry out a full survey and interpret the results and provide guidance to level 1. And if you are level 3 qualified, you can do all of the above and you can assume the full responsibility for training and certification. So the industry locally does not really aware of this level. I have seen level 1 foreign personnel arriving in Sri Lanka for service, and they provide reports, and which can be really dangerous. Actually, they don't understand the gravity of the action, but level 1 competencies can get you into trouble if you are obtaining the interpretation from them. They don't fully understand what they're saying. So make sure you get the service of a level 2 or above, or above qualified thermographer. And again, having said that, the level 1, level 2, level 3 is just the certification. It's just a piece of paper. And there are many online courses to get this certification. I was actually offered these certifications free of charge. I mean, not free of charge. You don't really have to go through the lectures or the evaluations. You can just pay the specified amount and get the certificate under your name, which is not the right way to do it, right? We should always seek the knowledge in something. That's my view, because these certifications, these degree certificates we have, they're just piece of paper. Without the proper understanding and the experience, these are useless. So make sure, if you are interested in this trade, make sure you seek the knowledge. You make sure you seek the expertise. You make sure you listen to the others, listen to the other professionals, what they have to say. For me, I have been exposed to many foreign experts on this. It has been a life-changing experience, interacting with those professionals, because they have so much to offer. These professionals, they have been carrying those huge cameras in the 1960s or 70s. They have seen it all, because they have much to offer to us, and their experience are far valuable than this piece of paper. So my advice to you on this is to keep reading, keep listening, and keep interacting, keep sharing ideas, keep talking to each other. That is how we can, stop. Maybe someday we will be able to do this in-house, because we have been doing in-house service for a long time. Many organizations nowadays, which is really good, because this type of knowledge is not very advanced and easily realizable in the local aspect. So, developing potential locally. So this can be you. This could be you. Hope you guys can see this image, right? Okay, you can see it. This is you, and that's your thermal imager that you have brought to your organization recently, or maybe many years back. If the nature, if the situation is like this in your organization, if you are not using your imager like you are supposed to, if you are keeping the imager and in its hard case in that cabinet and worshiping daily like these people are, you light up some joysticks and you light up some candles and worship every morning and every evening, you are doing it wrong, my friend. You should be taking it out and working with it. Unfortunately, this is the case in many organizations in Sri Lanka, as we have seen. They think that this is a really expensive equipment. That is true, but that does not mean that it has to be this way, right? You bought it because you want to use it. So use it. If you don't know how to use it, get a help from a professional and um, get their help. How to use it. Train them. Um, deploy this and get the work done. And if you have a device, first realize the true strength and the capability of the hardware. And understand the deployment, what the deployment of this device and the technology in your organization can do, which is really massive. You already have the device and just deploy it. Start using it. Take it out and using without worshipping like these people, right? So, like I said, training is really important. Training will really open your eye how you can enable the full potential of this technology and keep the qualification levels, certification level in mind, and always check the experience of the employer and your service provider, and they must have experience in this kind of work because the certifications are very common these days. You can buy it. Certification is just a piece of paper. So be mindful. And so if you have image, do some training in-house. Don't worry too much about the certification. First, get the basic training on maneuvering the equipment. Get the basics. Get someone to train you. Learn the basics. Start using. And when you start using it, you will adjust and you will learn. You will make mistakes and you will learn. You will know how to maintain the equipment. You will know how to capture images. You will know how to report them. You will know how to evaluate them. And worker empowerment and engagement. Like I said, you have to train your staff. You have to train them. You have to trust on them. And organization must have a framework for activation, deployment, and the sustainability of this kind of exercises. Yes, we always see operation versus maintenance mindset. That is very common, not only in Sri Lanka. I have heard the same thing from international consultants and trainers. They have always seen this. But without the support and the active participation of both the operations and the maintenance, just don't buy this equipment. Just don't invest. If you are sure that you cannot get these two groups to interact each other and work together for a infrared thermal imaging survey and condition monitoring, don't bother in investing on a device. So that has been proven around the world, and by his book, Engineer Ramesh Gulati, his book is about reliability maintenance, best practices. His first chapter start with his own experience, and man, that's so life-changing and so empowering and so inspiring. His book, you should read it. And he very well explains the engagement of the both groups and the cruciality of it. So if you are going ahead with it, please keep this in your mind and stay in the game. Really, really important. You need to see images on a daily basis. Not only during your surveys, you can talk to other professionals and check their images, how they are doing it and why they are doing it, and what you can see and capture from them. You can ask them. For example, I would like to share my personal experience on this, because lately I have been very inactive on Facebook. That is because I have been active on LinkedIn, where I have my professionals, or my peers, my international partners there. They, when I go to the LinkedIn, what I see is always I see these thermal images they have captured. They have captured high voltage equipment. They have captured horses. They have captured cattle. They are doing aerial surveys through thermal imaging. They are doing SAR missions like that. So I am always staying in the game. If you cannot stay in the game, you will use your touch, like similar to any other trade or any other aspect in life. If you are staying in the game, you will have the touch, you will learn, you will see. So that these are very important. All right. Questions? Thank you so much for listening, and this has been amazing. If you have any question, I would love to hear all your views on this. Thank you so much. Priyanka, over to you.
Thank you so much, Engineer Shami, for the valuable presentation. It's indeed a very eye-opening experience for all of us. So if anybody in the audience have any questions, you can unmute yourself and ask now.
Shami, can you hear me? Shami?
Yes, Himal, I can hear you.
Yeah, I'm not very familiar to engineering society actually, crowd. Thing is, I have a couple of questions to you, Shami. As a doctor regarding fighting in the COVID battle, do you have any recommendation or place to calibrate our infrared thermometers?
Infrared thermometers actually, Dr. Himal, they are factory calibrated. If you have purchased these devices very recently, they have a very fairly acceptable factory calibration. But if that does not satisfy you, you can there are ways to calibrate, because these black body radiators, there are things called black body radiators where you can calibrate these devices. But I don't know whether they have any in here. I have been also speaking to these Slintech guys about this, and I am yet to receive their word on this. But these black body radiators, I think you can ask from physics departments, University of Colombo, Department of Physics, and Calanio, maybe places like that. Because it's very important that you maintain the calibration, because what you are looking at is your devices. These are body temperature screening devices, which usually claim that they have about 0.2 to 0.4 Celsius degrees calibration, which is really high end, really advanced. Because it's important that you, I think these black body radiators, there should be couple available in Sri Lanka. I will try to find myself, Himal. I will try and let you know.
Thank you for that.
In the meantime, you can talk to the Colombo Faculty of Physics and departments like that. I think they should be having some academic purpose black body radiators with them, which should be able to calibrate your devices.
Yeah, what we do here is we use infrared guns and thermometers to detect the fever and get the actual value. We use all the method than all thermometer, that mean mercury based. So what we come across, if you can go beyond about 2000 readings, so it's documented in their browser as well. We have a low effectivity. I mean, the sensitivity is going down.
Yes.
Emissivity is going down. Maybe that the optical lens issues when we doing alcohol rub and other things, it can happen.
That's right. Exactly. The solvents will not. I mean, they are really toxic for the lens. That's the thing. Yeah, I think.
Yes. The second one is now is there are upcoming evidences when you detect, you can detect in body temperature in certain areas, especially when we discussing joint diseases such as rheumatoid arthritis as well as local infections. you have a locally increased temperature points. So now they have discussed and they are going to couple it with the ultrasound and MRI. So I think the developing technology, the engineers like you can join your newer evidences as well as experience to develop these things, and it's still in under development. And I want to suggest that you better go ahead and research on that level. So it will be very effective when we detecting early disease. So anybody can detect a disease when it's going along. Important is detecting early. So infrared comes to that point. So I just read about after your presentation. Yes, thank you, and thank you very much for your wonderful presentation, Shami.
Thank you so much, Timal. I will definitely check out these medical developments because it is important that we bridge the medical and engineering dimensions to achieve something greater. I'll be speaking to you on this, Himal. I'll give you a call. Thank you so much for your questions. Great questions. Thank you.
Any other questions from the audience?
Hi, I am Nadira here.
Yes, Nadira.
Yeah, this regarding the question Dr. Himal asked. It's not a question here from me. I recently found out that ITI, Industrial Technology Institute in Colombo 7, they do the calibration of the thermal images. If the calibration needs to be done. Yeah,
Yes.
just right to that.
Himal, so you can contact the ITI then.
Yeah, they do it. They have a calibration for these thermal images and this thermal range.
Okay.
Yeah, thank you very much for the information. I like contacting. Thank you.
Okay, thank you. Great.
So if there's no other questions, I hope we can wind out the session. So on behalf of IT Young Professionals Sri Lanka, I thank Engineer Shami Mudunkotuwa for his valuable presentation today. In fact, I forgot to mention earlier, he was the chairman of IT Young Professionals in University of Moratuwa when we started volunteering with IET. So he was the person who inspired us to join with IET and continue this far. So thank you, Engineer Shami, for that as well. We hope to continue working with you in our future programs as well. So thank you very much, and I hope everyone will also join in our future webinars. We have another one in next week as well. So keep in touch with us on our social media accounts as well, so that you can get the information. So thank you again, everyone. We hope to see you in our future webinars. Good night. Stay safe.
Thank you. Bye.